Geometry, we are back for Unit 1 Big Ideas, Packet 2. Alright, so previously we introduced the idea of 4 transformations, right? 4 transformations. We said translation. That's what we studied last packet. And those are slides. So you're sliding up, right, left, down. Number 2 was reflections. We'll be studying that today. So when you think of a reflection, think of yourself looking into a mirror, right? Your image is flipped. So I can describe reflections in one word, and that's flips. All right, we heard about rotations. We're not going to get into them today. And then we also heard about dilations, right? Dilations, where we change the size. We also heard about rigid and non-rigid transformations. We know that 1, 2, and 3 are rigid because they stay the same, we just move them or flip them, right? So rigid means same shape, same size. Dilations are non-rigid because we change the size, right? But the shape is still the same. All right, so transformation, an operation that maps or moves a pre-image onto an image. So our examples, I'll just do a little arrow. These are our transformation examples. We have 4 of them. All right, so we said reflection today. It's a flip. You're flipping the image. All right, so a type of rigid transformation, and again, it's rigid because same shape, same size. Oh my gosh, I meant to write same. I'm losing my mind. All right, same shape, same size. All we're doing is flipping it, but that's why it's a rigid transformation. So we're actually flipping it over a line of reflection, right, or a line of symmetry. You see this line of reflection there? We're taking this triangle and just flipping it over the line, so they're mirror images looking at each other, right? All right, so reflective symmetry. Mathematically, an object exhibits mirror symmetry is said to be invariant under reflection, meaning that reflecting the object in a certain way does not change its appearance. So this has 2 lines of reflection, right? If I took this paper and I folded it, those squiggly marks would match up exactly. If I folded it hot dog style, or hamburger style, whatever style that is, whatever style you're hungry for, these would match up as well. So this actually has 2 lines of symmetry. So let's take a trip to the museum. Let's look at some artwork here. All right, this is reflective artwork, right? Now, where is that line of reflection? Will I draw the line of reflection right down the middle? Yes, but am I drawing it horizontally or vertically? If I fold the image on top of each other, what line would make it look exactly the same? So if I drew a line horizontally, let's just pretend that's a line. That's a really bad line. So if I folded it on top of each other, it would pretty much match up, right? The sun, or I'm sorry, is that the moon? The moon would match up with the moon, and these trees would match up with each other, right? Now, on top of that, this looks like it also has a vertical line of symmetry. Oh my gosh, these lines are terrible. So if you folded the paper along those lines, it looks like it would match up as well. This tree and this tree would match up and so on. So this has 2 lines of symmetry. All right, let's look at another example. Or my mouse isn't working, so we'll go back to the paper and I'll come back to the other example in a minute. All right, parallel lines. 2 lines on a plane that never meet. They are always the same distance apart, so we call them equidistance, which means equal distance apart. So these 2 lines will go on forever in either direction and they will never meet. We designate parallel lines with a little arrow like this, and we'll use that designation more in Unit 2. All right, a few more definitions I just want to cover. Rectangle is a quadrilateral with 4 right angles. We should know that right angles mean 90 degrees. All right, so it has 4 right angles. A parallelogram has 2 sides that are parallel. So this side and this side would be parallel. This side and this side would be parallel. So its opposite sides are parallel. A trapezoid, it's a four-sided flat shape that has straight sides and one pair of parallel sides. So you can see that it's already marked. Right here are parallel marks. These two sides are parallel. These two sides are the same length, right? They're congruent, they're equal, but they're not parallel. And our last definition of our last vocabulary word is regular polygon. So a polygon is just a shape with a certain amount of sides, right? So a polygon that is equiangular, meaning that all the angles are equal, and equilateral, meaning that all the sides are equal. We call that a regular polygon. So that means every single angle in here is the same measurement and every side is the same side length. So that's what we would call a regular polygon. All right, go ahead and pause the video and review some of these definitions because there will be some definition questions on the quiz. So go ahead and get some of these definitions now. Okay, I'm on the next page. So don't get too excited, but we're going back to algebra for a second. So there's some skills that we need to know, some algebra skills, in order to perform geometric reflections. So this is why all your math classes build on each other. So you need to succeed in geometry so you can succeed in additional math classes afterward. All right, so let's take a look at this algebra review. If a line goes through the x-axis or has an equation of x is equal to some number, like x equals 2 or x equals -4, then it's a vertical line. So it's missing the y variable. And this is important because you need to know how to graph vertical and horizontal lines because they're going to be the lines of reflection that we're reflecting figures over. All right, if the line goes, so that's a typo I made, if the line goes through the y-axis or has an equation of y equals some number, like let's say y equals 3 or y equals 5, then it's a horizontal line. So you know it's a horizontal line if it's missing the x value in the equation. All right. If the line is vertical, then it's x equals something, right? If the line is horizontal, then it's y equals something. All right, so looking at this, y equals 1. Is that a horizontal line or a vertical line? It's missing the x value, so I hope you said it was a horizontal line. All right, x equals 0. It's missing the y value. It only has an x, so that makes it a vertical line. All right, pause the video and try the last one on your own. All right, I hope you said that it was a vertical line because it only has an x. It does not have a y value. All right, looking at this, equation of the line. So it's a vertical line, so I know it's going to start with x equals a number. But what number exactly? And I know it's kind of hard for you to see this line, so I'm going to highlight it. So it's going right through the number 2 on the x-axis. Do you think that's a coincidence? I hope you said no. So the equation of this line is x is equal to 2. And it's a positive 2 because it's to the right in these positive numbers. See, these numbers are positive and these are negative. So that's it. All right, I want you to go ahead and pause the video and tell me the equation of this line right here. All right, you're back. All right, I hope you have an equation right here to compare to mine. So you'll see that it's a horizontal line, right? It's different than this vertical line. So if it's horizontal, that means I have to use y. Y equals a number. I don't have any x in this equation, just like this equation did not have any y in it. All right, so if I have the equation y equals a number, what number should I use? Well, we should use the number that it's going through, right? This point right here isn't labeled, but I can see that it's exactly between the 2 and the 4, so it must be 3. So my equation here is y equals positive 3. And it's positive because we're above the x-axis, not below. All right, So that was vertical and horizontal lines. Now let's look at diagonal lines. So I know you covered this in algebra because I'm teaching algebra, so I know it's on the curriculum. So the slope-intercept form of a line. You're going to recognize it. You're going to kick yourself when you see it. Y equals mx plus b. So y equals mx plus b is the slope-intercept formula. The slope is represented by the variable m. That's what the slope is. The b is the y-intercept. I know it's all coming back to you, right? All right, so if we're going up the hill, like this right here, and remember, you're going to read the graph just like you read a book, right? You read sentences from left to right, so you're going to read this graph from left to right. So if you're going up the hill from left to right, that's positive slope. If you're going down the hill from left to right, that's negative slope. All right, so we have two simple lines where the y-intercept is 0. The y-intercept is 0 because the lines go right through the origin, right? That's where it hits the y-axis. So we don't even need to worry about b in our formula. We just need to find the slope. All right, so y equals x. Our m, looking at this formula right here, this equation, our m is the coefficient in front of x. It's that number in front of x. And when you don't see a number, you're going to assume that it's 1. So it's a positive 1 because there's no negative sign. And again, you don't see any y-intercept, right? There's no b. I already said b is equal to 0, so they just didn't write it at all. So looking at this, my slope is 1, my y-intercept is 0. This is what it looks like graphed, right? My slope is a positive 1, and it's going positive from left to right, plus 1. And I'm going up 1 and over 1, up 1 and over 1. So the line y equals x looks like this. Now this is important because this is a common line of reflection in geometry. The other common line of reflection in geometry is y equals negative x. So looking at this, our m is going to be negative 1 because the number in front of x is a negative and we don't see it, so we assume it's a 1, negative 1. And then our b is 0 because there is nothing after this negative x, right? So looking at this, this is how y equals negative x is graphed. We're going down, over 1 and down 1, over 1 and down 1, and it hits the y-intercept right at the origin. So this is what y equals negative x looks like graphed. All right, I want you to pause the video and try and see if you can label which line is y equals x and which line is y equals negative x. My lights just turned out in my classroom. Hello? Okay. All right. Pause the video, try it, come back. All right. So I'm going to highlight them with colors so we know which one we're talking about. So this yellow one that I just highlighted, looking at it, you can tell from left to right it's going up, so it must have a positive slope. Of these two equations, the only one with a positive slope is y equals x. So this line right here is y equals x. All right, what about the pink line? You only have one other option. So it's going down from left to right, which means it's negative. So this is y equals negative x. And again, we haven't even gotten to the geometric reflections yet because we're reviewing this stuff because you need to know it before we do reflections. If you're confused on any of these concepts, I want you to go back and watch the video again about horizontal and vertical lines and diagonal lines, y equals x and y equals negative x. We'll pick up with the reflections in our live session next class.